Good morning. I'm Kaushal Chari, Dean of UWM's Lubar School of Business. I'm so delighted to welcome you to today's Artificial Intelligence and Analytics Symposium. The Lubar School is very proud to offer this webinar to the public, sharing the expertise of top academics and executives, and our own outstanding faculty on the latest in both research and practice in AI and analytics. This webinar is sponsored by the Lubar School Center for Technology Innovation, which fosters a community of faculty, business leaders, and students to explore the opportunities offered by innovative technologies such as AI, machine learning, and big data. And through public programs like today's symposium and its long-standing workshop series, the center seeks to promote discussions that lead to solutions in the information technology environment. I'm now happy to turn the program over to Dr. Atish Sinha, Professor of Information Technology Management and Director of the Center for Technology Innovation at the Lubar School of Business. Dr. Sinha is an expert in business intelligence, service-oriented systems, and connected systems. Atish, thank you for organizing today's symposium. We are really looking forward to all the insights from experts in the spheres of AI and analytics. Over to you, Atish.
Thank you, Dean Chari. Chris, can you let me share the screen?
You should be able to go ahead.
Thank you, everyone, for joining in the symposium from all across the country. This is the second symposium we are doing at the Lubar School of Business. I want to thank our sponsors, Church Mutual, SAP, Microsoft, and Rockwell for their support. We have two keynote addresses, one in the morning and later one after the break. There are two panels, an academic panel on algorithmic decision-making and a second industry panel on AI analytics in practice.
Thank you all for being here. I'm Mark Schreit. I'm the Associate Dean here in the Business School. I'm also one of the professors in IT Management, and I'm going to moderate our first panel. The first panel is on algorithmic decision-making. Algorithms are playing an important role in decision-making in our everyday lives. While often influencing our micro-level decisions like which songs we listen to, where we eat, which shirt to buy, algorithms are also beginning to play a role in a more significant decisions that greatly influence society. These more impactful decisions include judicial parole hearings, medical diagnoses, loan approvals, autonomous driving. In theory, these technology artifacts can lead to fair and objective decision-making. However, like humans, they have their share of biases in practice. This uncertainty around performance can make some people apprehensive about these technologies playing a more prominent role in society. This academic panel will discuss algorithms, how algorithms can aid both human and organizational decision-making, where they perform well and err, and how to design these artifacts for a better, more productive world. We've got 3 experts on the panel and 6 questions ready to go. I'm going to give each question, it's going to work out to about 6 or so minutes. Again, if the audience has questions, please put them in the Q&A and we'll get to those probably towards the end, like we did with Jeff's session. I would like to take a minute and let our panelists introduce themselves. If you could each take about a minute and tell us about your background and your research interest in this topic.
So I can go first. Hi, I'm Scott Shanke. I'm an assistant professor here at the University of Wisconsin-Milwaukee in the Information Technology Management area. My research basically seeks to identify and quantify sort of these effective approaches to design and implement sort of entities that represent, firms and brands and sort of these customer interactions. So think AI-enabled conversational agents, digital brand personalities, and things like that. A lot of, kind of how I kind of tackle some of these questions. I address them through both sort of, lab experiments as well as field experiments in partnership with companies.
Hi, I'll go next. My name is Antino Kim. I'm an associate professor of information system at Kelley School of Business, Indiana University. My research is sort of all over the place, but specifically in the context of AI and machine learning, I'm primarily interested in user acceptance. For example, using chatbots in healthcare industry to provide, say, health-related information, diagnosis services, triaging services, using digital humans to provide customer service. That's fun. And I'm also interested in socioeconomic implications of algorithms in general, such as job displacement. So yeah, pleasure to be here. I'm happy to share my thoughts and learn from others as well.
All right, I'll go. Hi, everyone. First of all, thanks a lot for having me on the panel. My name is Moxen Yang. I'm an assistant professor at the Information Decision Science Department, the Carlson School of Management at University of Minnesota. First of all, both Scott and Antino are two of my dear friends. I shared several years with Scott in the same office as PhD student, and Antino is one of my great co-authors, actually on an algorithmic decision-making related paper. So my research largely fall into the bucket of algorithmic decision-making. I design new algorithms, machine learning algorithms, to help people make very challenging decisions, both for individuals and for organizations. And I also look at the factors that affect the adoption of algorithms in different decision contexts, as well as the implications, social implications of algorithmic decision-making, specifically in the area of fairness and privacy. So looking forward to today's discussion.
Okay, thank all three of you for jumping in there. I'm going to start out with our first question, which is basically, should algorithms be trusted to make everyday decisions? Any one of the three of you want to jump in with a thought or two on that, please?
Yeah, I guess I can
know
take
what
a
Moxen's
first.
gonna say.
I guess I can take a first stab at this. So my answer to this, which is probably going to be my answer to every question today, which is it depends. Depends on which everyday decisions we're talking about. I am more than comfortable in relying on algorithms to make my consumption decisions, like the movies that I watch, the music I listen to, the restaurants I go eat at. I feel like recommender system algorithms in particular are very good these days to discover my preferences and surprise me from time to time. So from that perspective, I'm happy to trust algorithms. I trust algorithms more than myself, usually, on those consumption decisions. When it comes to decisions that are higher stake, for example, my health or the health of my family members, I tend to give more caution and sort of think twice before I trust algorithm decisions. I want to have human validation as well.
Other two of you want to?
Yeah, so I mean, I pretty much, kind of echo sort of what Moxen says. But I mean, on at the same time, I think over-reliance on algorithms for your everyday decisions can be bad, right? So for some consumption decisions, I think, you can rely on algorithms. However, there are certain things that are sort of innate in the human experience. So if you think about, one of the things that I use or maybe even over rely on is Google Maps, right? But there is some evolutionary sort of things going on in terms of kind of understanding mental maps of your surroundings and things like that. And if you take that out of the equation, there has been shown some impacts on sort of your mental health and sort of how you kind of your brain health and longevity. I think also, we sometimes overly rely on algorithms, we as educators kind of see this in sort of, things like photo math. I don't know if you've ever seen this algorithm that basically can solve math problems for you. There's a new GitHub Copilot that just came out that might give you the right answer for, some sort of coding solution or something like that. But I think it makes us, kind of takes sort of critical thinking out of the equation. And I think critical thinking is really important for us as human beings.
So in a nutshell, I agree with both the panelists that it's not really a matter of should, but more a matter of when and how much, right? And so short answer, it depends. And the question then is, what does it depend on? And I think it might help to think for mental compartmentalization, some of the factors into dimensions. The first dimension will be, largely speaking, performance, tech maturity, algorithm maturity. So how well does it perform? What kind of errors does it make? Error rate, accuracy, precision, and all that. And also, it's about the context, as Mochen put it, right? If something goes wrong, what is the impact? So the risk, when we're talking about risk, there are two parts: the likelihood of bad things happening, as well as the impact. And what Mochen was alluding to was, well, if the impact of bad things happening is relatively light, it's just recommendation system, I just wasted an hour and a half for watching crappy TV show that I didn't like, versus is it cancer or is it not? That will actually determine whether or not algorithms should be confidently used to make decisions. The other dimension, first dimension is performance, second dimension, I would say, is largely speaking acceptance. It has to do with user acceptance. And this is related to, but also separate from performance itself. Even if the algorithm is mature, it performs well, if people are uncomfortable, if there's a general cultural reactance against using algorithm, then it's not going to work, right? So we also have to think about users acceptance, and as well as let's say if we're talking about, I think we're in the previous keynote, there was a discussion about self-driving cars. Well, then if you're talking about self-driving cars, then of course we got to think about the legal as well as infrastructure support around it, and all those would determine whether or not and whether we should rely on algorithms to make decisions.
Okay, great comment, because that leads us into our second question, which is, how can we make individuals more accepting of algorithmic decisions?
Yeah, I think Antino's answer to the first question actually provides a great framework for us to talk about the second one. So first dimension, he talked about his performance. So how do we make people accept algorithms or algorithmic decisions? Well, build better algorithms that are more robust, higher performance, that adapt to changing situations, all those things that you could think of. But at the same time, we also sort of want to be aware that no matter how hard you try, algorithms are tools, and they're not going to be 100% perfect. There are good, there might be good tools and bad tools, but even the good tools are going to make mistakes sometimes. So to make people comfortable in using algorithmic decisions, I think there also has to be considerations in terms of how you expect people to use it. And this is actually one of the core ideas that Antino and I work on with one other faculty member at Indiana University. We believe that giving people control over how they use the algorithm is going to be a big element for encouraging adoption. And specifically by control, I mean we are not completely delegating the decision to an algorithm that we may not fully understand or we may not fully trust. We don't live in the matrix yet. Instead, we are working together with the algorithm, using the algorithm as a decision support tool. And the humans are still sort of in the driver's seat, so to speak, making the final decision, taking into account the suggestions or the extra information provided by the algorithm. So control and performance, those are the two things I would sort of highlight.
I'm a little concerned about the fact that Mochen said we're not in the matrix yet. Hopefully never. Now, I agree with all the points that Mochen raised. A few things to add. Since I was talking about risk, the one way to reduce risk is to reduce likelihood of bad things happening. So better algorithm, as Mochen said. The other dimension is to reduce impact, right? So, introduce algorithm in less critical domains first, if it's not mature enough. It's akin to the idea of letting users warm up to algorithms. And that would be one way to encourage acceptance of algorithms in general. And also, this is for reasons that I don't quite get, because perhaps it's because it's too obvious. Campaigning, informing users that algorithms capability, right? How algorithms work, that will also increase overall reliance and acceptance in algorithms, because this is something that we, in our field, we refer to as algorithm aversion. Users are typically averse to the idea of relying on algorithms, especially when they witness algorithms making mistake. In one of my projects where I study using chatbots to provide COVID-19 related information, especially at the early stage of COVID, there was this huge uptick in the number of people trying to get information. They were panicking. Do I have COVID? I traveled recently. Should I go see a doctor? And since there was a surge in demand, we needed some technological solution to address that demand, and chatbot seemed to be a perfect solution. And what we did in that experiment was we provided one script, right? Just talking about symptoms and providing some diagnosis information. It was identical across 2 different treatments, but for one treatment, we said, this is coming from human agent. For other treatment, we said, this is coming from chatbot. And interestingly, again, remember, the script was the same. People thought the script, the script that came from chatbot, or supposedly, was less trustworthy. It wasn't as reliable. You couldn't trust what it was saying. The perceived ability was lower. So there's this general negative bias towards algorithms. And if we can address that, if we can let users know, hey, this chatbot is providing same kind of information that a trained agent would in that particular context, then perhaps we can remedy that. Another interesting part of that research was when we controlled for that negative bias, basically other than that part of the equation, people actually preferred interacting with chatbot and getting the same information than interacting with humans. So there's something to be learned there.
Yeah. Just to, I agree, I think mostly with, Mochen and Antino here. One additional point that I think could help go a long way with sort of people's trust in algorithms is if there's a little bit more government oversight in the space. I think, if you think about medications and things like that, we have the FDA in the United States, but there aren't really a whole lot of, laws and kind of safety precautions for algorithms. So I think if there was some sort of some more consumer protections, I think specifically California has this law called the Bolstering Online Transparency Act, which forces organizations managing chatbots and things like that to basically disclose that their agents, if they're automated, that they are AI. And if you don't do it, basically, you can kind of expect some hefty monetary consequences. So I think if there were more of these types of consumer protections that were audited and made sure that they were adhered to, I think people would also feel a little bit better towards kind of interacting with algorithms as well.
Okay, thank you all. Question 3 has to do with documentaries like the recent one called Coded Bias, highlight disparities in the efficiency of algorithms and unintended outcomes for minority groups. How do these biases occur, and in what ways can we prevent these issues from occurring in the future?
So I can.
First of all, does everybody know what the documentary, Mochen?
Why don't one of you give us a 30-second?
I haven't watched it, so Antino, maybe you want to go if you have watched it.
It's on Netflix. Full disclosure, I haven't watched it. I've watched the trailer, and I know what it is about because that documentary is actually based on a very famous incident where this facial recognition software, this MIT researcher figured out that this piece of technology, facial recognition software, cannot recognize faces of minorities, right? People of color, it just cannot perform. whereas it had no trouble recognizing faces of white people, right? And so the story starts from there, and it's revealing some inherent biases that exist in machine learning algorithms. And this researcher goes on and brings this issue to light and discusses, and basically it's about raising awareness of biases that might exist in machine learning algorithms.
Yeah. So let me take a try at this question. So this algorithmic fairness question is very, the landscape is very complicated, as you might imagine, for any kind of fairness or ethical related issues. So the algorithmic bias arises from multiple different sources. It's not just one problem that's causing this. One primary source of bias is the data on which the algorithm has been trained on. So these data, as you can imagine, for decisions that the algorithms want to make, algorithms have to learn from historical decision instances. And most of the time, these historical decision instances are made by humans. And we all know very well that humans carry a lot of biases towards minority groups, towards different gender groups, towards anything you can think of. So in a sense, the bias is embedded in the data on which the algorithm is trained, and the algorithms learn from that in order to make decisions. So the algorithm might inherit the bias from the data. The second source of bias is the way the algorithm is designed and the way that the algorithm learns from data. I have a very realistic view of artificial intelligence or machine learning in general, in the sense that I believe, even the very advanced ones today, they are mostly pattern recognition tools. They're trying to find patterns from the data in order to make predictions that are as accurate as possible. Now, by that nature, they're going to take whatever information that gives you the highest improvement in performance, in accuracy, and use that to make prediction. And unfortunately, in a lot of sort of social related decision making, that predictive information is going to lead to biases. And the third source of bias is sort of subsequent decision making. Once the algorithm generates some kind of prediction, usually it's the humans that have to make the final decision. And in high stake scenarios like healthcare, school admission, or parole hearing, and they might, even if the algorithm is okay, they might reintroduce their bias into the final decision. Now, towards the final part of this question, how can we address that? That's again a $1 trillion question. But the perspective I would sort of advocate here is that just like the fact that there are multiple issues causing the bias, it's going to take multiple perspectives and multiple mechanisms together to solve the bias. You're going to have to create more fair data sets. You're going to have to redesign the algorithm to take into account the fairness while it's learning from data. And you're going to have to educate decision makers in terms of how to take into account algorithmic outputs or recommendations towards a fairer outcome.
I think Moxen was very holistic in his answer, and perhaps answered that $1 trillion question. So it's quite interesting that previously I was talking about human biases against AI, and now we're talking about AI's bias against certain minority groups. And that going back to the previous item that we're discussing, that will severely hamper dampen the willingness to adopt algorithms from those target minority groups, right? Let's say if the algorithm is harshly penalizing minority groups, then people simply will not trust the algorithm. I think that's pretty straightforward. And these biases, they take many forms, much like how algorithms are used across many different facets of our society to make loan decisions, for example, housing, career, scanning resume. There was another famous example from Amazon scanning through resume and incorrectly concluding that, traditionally all these programmers are males. Hence, if the resume is from male applicant, it must be better than female candidates, right? So they scrapped the program once they recognized that bias. So again, all these things that Moxen mentioned, the biases in the data, in the implementation. So let me try to put sort of take a more high level approach, high level abstraction, taking a 30,000 feet overview. To vastly simplify the system, we have input, we have the actual algorithm itself, and we have the output, right? And you can think of it as a feedback loop where the decision made by the algorithm or subsequently by human agents gets fed back into the system in the form of training data. So when you see the overall system at that level of abstraction, the places where we can address this monitor for biases and address the issue become quite clear. We have to fix the input, right? Bigger data, more representative data, garbage in, garbage out, as we say. I completely agree. We humans learn through experience and observations. For algorithms, data is their experience and observation. So we definitely need to fix that part, as well as some inherent flaws that might exist in algorithms. And we need to monitor for biases in the ultimate decisions that algorithms make. We can't fix something that we can't measure. So we definitely need to measure biases. And fortunately, there are many different ways to measure biases. Biases tend to be context specific. That's why there are many measures. There are some more popular ones, such as like equalized odds. I'm sure Mochen and Scott are very familiar with them. And fortunately, the onus of looking for biases in algorithms, that does not fall entirely on any particular organization, thanks in part to organizations raising awareness, such as the organization featured in the Coded Bias documentary. So organizations, tech companies, tech giants like Google and IBM, they recognize that this is a serious issue. So they provide open source software tools so that to automatically test for like fairness using different measures of biases, fairness, so people can just take and use that. One final thought that I have is, as Mochen said, essentially algorithm biases are human biases. That's the root of algorithm biases. Looking for biases in algorithms could also give us a chance to look at ourselves in the mirror and recognize that we might have some biases in the society. I'm sure for those of you who are parents in this in the audience would understand when I say, sometimes I recognize my own flaws that I was completely not aware of by observing what my kids do by mimicking my behavior. And I think very similarly, by looking at what biases might exist in algorithms, we can also recognize some of the biases that exist in the society. For example, that coded bias documentary, that facial recognition algorithm not being able to recognize faces of minority. That probably happened because they did not have people who are not white to test the algorithm, right? My friend always says whenever you see a case of, say, mistake or somebody doing harm, and you're not sure if it's malice or incompetence, always bet on incompetence. And of course, I'm not saying the programmers are incompetent. I'm sure they're very, very smart people. It's just, as a society, as a group, we tend to be blind towards our own flaws, our own biases. And I think, let's say, more diverse AI, groups, more representative AI group, that might be part of the solution.
Scott, you've been quiet.
Yeah. So I once again, I agree a lot with Intino and Mochen here. I think a lot of the biases come from sort of this data that reflects human biases that exist in our society, right? So like there's the Compass algorithm that's kind of used to predict recidivism. And if you look at sort of the historical data that makes these predictions, the data would basically just pick up on a lot of these social biases that exist in our society. Also kind of to Antino's point, sort of the incomplete training data, right? So, if you look at some of the AI voice technology, I think there was a Proceedings of the National Academy of Sciences paper that just basically says that, a lot of these voice activation tools or, kind of these Alexas and things like that work very well for, Caucasian voices versus, other minority groups. So a lot of it is, the data that's there, there could be some sort of reflection of some of these, socioeconomic differences. If the large majority of sort of more wealthy people, are able to have these, technologies, then a lot of the data that's being used to kind of make these things a little bit better, is kind of, biased in that regard. And then, a really small, granted, I think the large majority of these, kind of the data is kind of the reason for a lot of these biases. But, I think a lot of folks, are always concerned that there might be biased programmers out there, people that are creating these algorithms, maybe include, variables and models and things like that maybe shouldn't be there. So, having some sort of training or, sort of simple reminders for these folks, might also be beneficial as well.
Okay, let's move on to question 4 then. Thank you. Which is, in your opinion, where are the practical areas for organizations to deploy algorithmic decision making? Where might algorithms not perform as well? So 2 ends of that one.
So my sense on this question is that it depends on the type of algorithms, or more specifically machine learning algorithms that we're talking about. Broadly speaking, and just for the sake of making my point, let's consider either sort of the predictive algorithms, the algorithms that computer science calls supervised learning algorithms that are trained based on some input and try to produce some kind of prediction as output. Usually that works well with more works well with more data, both in terms of quantity, in terms of quality. So the area of organization where that will be most helpful is the data intensive ones. Things like marketing, things like HR, where you have a constant flow of authentic data, that you can leverage to continuously improve the algorithm. And it is already being deployed in those domains, very, very, in a relatively mature state. So that also answers the question where this is not performing well. It's going to be in the places where the data is very sparse or very low quality, a lot of noises. For instance, if you want to learn some kind of algorithm from 2 data points, it's not going to work well. So that's sort of my overall take. Now, there are other type of algorithms which we broadly call reinforcement learning algorithms. So I think Jeff's keynote gave a very good example of that, which is the algorithm that's playing AlphaGo. So these are the type of algorithms that learn to make decisions. They don't learn to make predictions per se. They learn to make decisions usually in a kind of sequence. These algorithms, in my opinion, are most useful in areas where the environment, when the algorithm interact with the environment provides very accurate and timely feedback in the sense of reward. Just like when you're playing a game, you interact with the game and the game provides you with feedback almost immediately. Okay, and reinforcement learning algorithm really strives in those kinds of situations. On the other hand, it doesn't work that well yet in situations where the feedback is very sparse, or you only get a feedback 5 months down the road or a year down the road. So specific example in organizations like high-level strategic decision making, like what are the strategic directions that the company should go. I don't think we're anywhere close in using algorithm to make that decision directly.
Other thoughts?
Yeah, I mean, oh, go ahead.
Go ahead, Scott. Sorry.
Okay. Yeah, no. So no, I agree. I think algorithms perform pretty well in sort of these concrete decision tasks that can be routinized. I think a lot about kind of like where can chatbots or AI kind of be injected in sort of human-facing job roles and things like that. And Jeff actually sort of kind of talked a little bit about that. I think we're starting to see it in really simple context, right? Image classification, text classification, risk assessments, and rudimentary roles. I think what's interesting, and I don't know if anybody here has been kind of following Twitter, but some of these unstructured tasks as well, like more creative tasks. DALL-E, I don't know if DALL-E and DALL-E Mini basically can generate these new kind of images that we've never seen before. And I think, applications actually in sort of these more creative, areas of organizations, you might be able to use it as sort of kind of an assistant tool to kind of come up with new products, or come up with sort of logos and things like that. Where I think algorithms might not perform so well, I think back to kind of where Tesla tried to use AI and algorithms and automation in their creation of sort of the Model 3. And they basically just, overly relied on all these algorithms to kind of automate jobs and, kind of have this turnkey sort of manufacturing solution. And, they didn't really have a human in the loop for a lot of these job duties. And it caused a ton of delays in the delivery of the Model 3. So I think, I think algorithms can start to be applied to a lot of, variety of different sort of organizational initiatives. But I think just assuming that it's all going to kind of take care of business for you without having some sort of human in the loop, I think is where organizations can run into troubles.
Yeah.
So I completely agree with all the points raised by Mochen as well as Scott. I think this question is, it takes us back to our very first question, right? So the answer is, as Mochen said, it depends. I would actually expand the domain and say by algorithm, we're also talking about standard algorithms, not like machine learning. And already highly standardized tasks with predetermined responses or well-defined processes, they are already being automated using standard algorithms, and quite efficiently so. And jobs primarily comprised of such tasks are either being completely displaced or fundamentally being restructured. Right, so maybe some of the areas where tasks are well defined without many exceptions, those may be some good candidates where algorithm adoption would give you big bang for your buck, right? And there are other domains, as Mochen and Scott illustrated, that where algorithms, standard algorithms, as well as machine learning algorithms included, don't do very well because the tech is not very mature, maybe not appropriate, or maybe training data is not sufficient. And subset of such instances may require human intervention, as Scott mentioned in his Tesla example, right? And as Mochen already said, having human in the loop, putting people in the driver's seat, also has the positive effect of increasing acceptance, reliance, and errors do not deter them as much because it is people who are making the ultimate decision. So those are all important points to keep in mind. Overall, I'll echo what I said with the first topic. It will depend on overall performance as well as acceptance, and clearly neither of those dimensions are static, right? So my prediction is that the application domain will only expand over time. Algorithms will become more and more sophisticated. We'll have more training data, obviously, and not only that, people will become more. They will warm up to the idea of using algorithms in various different domains. There will be legal infrastructure support and so on. So that's what I foresee.
Okay, let's move on to the next question. This has to do with safety. Who should ensure the safety of algorithms deployed in our society? Is it government, the platforms themselves, or individuals?
So I'm going to give a short answer to this because I know we're short on time, but I'm going to answer it by not answering it. The perspective I take in terms of who should ensure the safety of algorithms is really actually cutting the algorithm a little bit slack. Who should ensure the safety of anything deployed in a society, right? So from that perspective, algorithm is maybe not extremely special in that sense. Who should ensure the safety of a new pill, of a new medical treatment? Forget about algorithms deployed in our society. Well, we have institutions. First of all, we have law. We have legal system that sort of chart out how you should think about this kind of new technology or new intervention. We have institutions like FDA that regulates the way you should test your drug, you should develop your drug, and you should market your drug. And we have specific corporate related, regulations and laws that tells, pharmaceutical companies in terms of what you should do and what you should not do. And then we have sort of downstream companies or individuals in terms of ensuring the safe distribution and use of that. So from that perspective, it's always going to take an entire socio-technical system to ensure the safety of pretty much anything, including algorithm. Now, maybe algorithm is special in the sense of its large, large and wide impact on many aspects of our life. But I guess the solution to that, we have been using that and we have been perfecting that and we have been debating that for hundreds of years, which is how do you design a socio-technical system to regulate new technology and new interventions in society?
So I will somewhat echo what Mochen has already said. It's all of the above. That's the simple answer. So all the players that you mentioned, government as well as platform as in individuals. So let me sketch it out. First player, individuals, right? In particular, let's talk about developers. Developers should act morally. And that might sound obvious, but it's actually quite complicated. Oftentimes, we don't even have consensus agreement as to what it means to act moral. Just recently, I saw an announcement by Amazon that they will release this new feature on Echo, where people can talk to their deceased by providing some voice clip. And there are debates about whether that's unethical, whether that's creepy, or whether that's sweet. Your late grandmother reading your favorite book to you. That's some people perceive it to be sweet. Getting into more, one of the examples that we talked about before, lack of representation in certain areas. People don't necessarily agree that's a problem. And among those who do agree that, we need representation in these fields, the urgency to which that issue need to be remedied, that also varies. So we need to have a consensus as to what it means to act morally. And I think on that note, that's why ethics training is such a crucial part in business education. That's something that we as educators can play a role in. I would think. And then staying in individuals, as consumers, we should demand socially responsible AI, right? Raise awareness. Previously in the coded bias example, I think I wrote it down somewhere. Oh, the researcher from MIT who started this whole movement formed this non-profit organization called Algorithmic Justice League. For those of you DC fans, yeah, you might like that. And the whole idea is raising awareness, campaigning, right? Because if you think about it, nowadays companies care about more than just profit. They have multiple objectives other than profit, such as sustainability, renewable energy, socially responsible supply chain. We hear that a lot, fair trade, and so on. And the reason why these companies got to care about those different objectives is because of campaigning and raising awareness. And of course, I am not naive. There might be some negative externalities that the market is not able to fully take care of, even with the raised awareness and companies taking those different objectives like socially responsible AI into account. For that, we need legal framework, right, to handle those negative externalities. As a matter of fact, I think that coded bias talks a lot about how in the AI, in the domain of AI, we lack the legal structure necessary to govern and protect consumers. So I'll leave you with that.
And I once again, agree with Antino and Mochen, but I do think it starts with government. Specifically, I think platforms at the end of the day exist to make money. While a lot of the social responsibility and things like that are are important. I think platforms out there want to try and make a buck or stay alive. So some of their recommendations may not be with the most altruistic intent all the time. And I think too, if you were to kind of put reliance on the consumer We know that a lot of times they get bogged down with, even just, privacy information, there are terms and conditions on websites and things like that, that they won't even look at. So I do think that, if you were to have sort of, government safeguards to enforce some of this accountability, I think that would be kind of the way to go. And then, everything else, that sort of socio-technical system would kind of follow suit.
Okay, great. Thank you for those thoughts on that, all three of you. Our last question of the formal ones is coming up, and then we've got a few from the audience as well. But question 6 is, should algorithmic decisions be more transparent, less transparent, or the same as humans making decisions?
So actually, this is a very non-trivial and non-obvious question. So I don't have an answer for this. And I believe this is one of the area of active research. So I could see the case for both, and it's probably going to depend on the specific application and the context in which we're talking about. So the case for making algorithm decision making more transparent is maybe it fosters trust, understanding how the algorithm works, and seeing that it is, maybe working in the expected or appropriate manner might help people to rely more on the algorithm. The case for making the case against that is in some highly sensitive area. Maybe that's a violation of privacy, or maybe by sort of making the inner workings of an algorithm more transparent, you're actually encouraging gaming behavior, which circumvents which actually can cause more harm. I know Do is actually giving a keynote on the related topic, so I'll leave that topic to him. One other thing is, it's not a matter of, let's make it more transparent or not. We don't actually have a very good idea of how to make it transparent. The way to sort of somehow explain algorithmic decisions, especially for black box machine learning models like neural network, which is the engine that powers a lot of the very well publicized applications like DALL-E and many AlphaGo. A lot of them is a black box by design. We don't really have a good idea how to make it transparent. So this is a very, very hard question. Yeah.
I was hoping that Moxen will have a definitive answer on this, but I think that he answered it as well as I could. So I agree with Moxen. This is a difficult question. So oftentimes we don't even have a clear definition as to what we mean by transparent, right? Are we releasing data? Are we releasing code? Or are we providing some sort of report? And also on that note, I'm not sure if human transparency and algorithm transparency is necessarily an apple-to-apple comparison where we can say, should we make it more or less transparent compared to human? For example, humans lie, right? Humans can lie, whereas algorithms are instantiated through codes, which is akin to the thought process of humans. And the codes are available in written form. Whether or not they could be disclosed is a separate issue because of intellectual property and and other issues that Moxen talked about, such as gaming, for example, or black box nature. So it is a difficult question. So what I will do is instead of answering that question, I'll answer another question. Well, something that I think is important for the audience to be cognizant of in the conversation, the discussion around transparency. First is that in the past, explainable AI is an active research area. In the past, people thought the general consensus was that for transparency, we needed to sacrifice performance. So there were two competing objectives. However, recent development, recent research shows that might not necessarily be the case. You can have improved transparency and improved performance at the same time. So this just kind of makes this, puts this whole issue of transparency in a new light. So something to be cognizant of. These two objectives might not necessarily be competing. They can actually be improved in tandem. So I wanted to bring that to light. The second aspect is, Moxen mentioned trust, right? Building users' trust. And that's actually one of the objectives, one of the main objectives, I would say, of improving transparency, because we don't trust things we don't understand. I was talking about how algorithms can be used to make loan decisions. If if I ask you, okay, how does it work? How does it make loan decision? And if the answer is like, I don't know, I'm not going to use that, right? I'm simply not going to use that. And so transparency is in part to improve trust and users' reliance on the algorithm. And on that particular topic, there's an interesting research work, not mine, but I found it very interesting, that shows that yes, people don't trust black box models, like completely obscure, like nothing disclosed about how the algorithm works. But at the same time, people don't need or even want extremely high levels of transparency where all the nuts and bolts are shown, the nitty-gritty details. They simply cannot comprehend. It actually negatively affects users' trust. So there's this non-monotonic relationship between transparency and users' trust. And what that implies, although there's no clear definition as to what do we mean, like what level of transparency do we want, what that implies in general is that there's this sweet spot somewhere in the middle, Goldilocks zone, where we have some medium level of transparency, which could perhaps be described as a setting where users are provided some statistical reports of major determining factors in this whole algorithm-driven decision-making process, and that might be enough if the sole objective is to increase users' trust.
Okay, Scott, do you have a brief comment? We're running out of time here.
Yeah, so I mean, I do think, one great thing about, algorithms is that there is, some degree of, it's a system, so it is somewhat systematic. The way that humans kind of make decisions, is still a very vibrant kind of line of inquiry in psychology and neuroscience. So, if there is some sort of auditability, on algorithms, maybe not necessarily for the users, and maybe something that, there is some sort of log somewhere. I do think that that's important, especially if there is some sort of, terrible thing that happens. If you think about sort of AI, self-driving cars, why did you, ram into this other car or a semi or something like that? Having some sort of, log of, why an AI kind of did what it did, I think is good, so that you can go back to it, which like isn't necessarily there all the time. If you think about, someone that, gets in a car accident, a lot of times they won't necessarily be as truthful maybe in what actually happened in a given situation.
Okay. Thank you. I know we wanted to answer some of the audience questions, but I've just been told by the organizers to move it along. Okay. So what I'm going to ask is maybe our panelists could take a look at them and answer them in the Q&A forum. They're about 1 or 2 each. Throw an answer to the people that had something, a specific question. At this point, I would like to thank our 3 panelists for being here and doing an excellent job of rolling through our topical questions. I also want to thank the audience of over 60 people that has been here for this entire panel. And I believe we have a short break before the next one, which starts in about 5 minutes. So hopefully we'll see everyone back for that. And we will do our best to get the Q&A answered. So thank you all.
Doing well. All right. Well, I'll do the introductions. Well, thank you so much. This is going to be our academic, keynote. So I'm pleased to introduce De Lu. He's the Jiandong Eric Jing Professor of Information and Decision Sciences at the Carlson School of Management at the University of Minnesota. He's a world-leading expert on gamification applications and systems. And he's been, published in a variety of very highly regarded outlets like Information Systems Research, Management Information Systems Quarterly, Management Science, Journal of Marketing, Journal of Marketing Research, and POMS. And he's also the associate editor of Information Systems Research and Journal of Organizational Computing and Electronic Commerce. In addition to all of these, professional achievements, I've had the privilege of kind of working with as well as kind of, experience him as a mentor and friend, and he's a fantastic person. So without any further ado, he's going to give a talk on AI, gamification, and the future of work.
Thank you, Scott, for a generous introduction, and I'm really honored to have this opportunity to speak and give me a chance to exercise my thoughts. And I want to start by saying that oftentimes as researchers we are super focused on a very narrowly defined question, and this one I actually decided, and also I was suggested not to do a very narrow research paper. Rather than I would like to share some general thoughts drawing from my own background in gamification research. And so my talk will be more coming from, will be drawing my experience in gamification research and start looking from the perspective of gamification at some of the AI and future of work issues. Let me share my slides. And here it is. So I like to start with some of the phenomena we've been seeing or people are discussing. This is I took a banner from Natural Science Foundation's Future of Work, and they have this depiction, or at least representing their views on what likely to be the future of work. And if you look closely at this graph in the bubble on the top left, it shows that one teacher is teaching several kids, and each of the kids in the bubble, they might be located in different locations. And they together kind of gather in this virtual space and look at the penguin, which maybe somewhere entirely somewhere else. And the teacher using some virtual, globe, earth to show them, illustrate, some knowledge and topics. And you can also see that in another bubble that on the top right, a person's looking at maybe a real-time dashboard. And this dashboard may be gathering some real-time information about the transportation system. Each of the vehicles might have their own Internet of Things device installed on them that transmitting real-time information. And this person's using some smart controls to kind of help with help with the performance of the transportation system. At the top left and the bottom right, you can see that maybe some scientist or parent is working in the agriculture fields. They might use some biotechnologies to actually getting some. I'm just guessing that getting some biological information about the plants there, and they have actually a dashboard showing maybe temperatures, biological makeups of the plants, and certainly it's so this is kind of interesting illustration of what the future lies for for our work. And I want to contrast that with the next picture I took from the promotional video for Meta. As you may know, that Meta is the Facebook renaming itself as Meta, and they Mark Zuckerberg presented a vision of him about the future of metaverse. And this, as the picture shows here, you can actually, as one way of future entertainment is you can gather in a virtual place with friends. Each of them have their own avatars. You can floating, play cards, and among on the table, there's even a droid actually is having their avatar, a droid, and they are actually having real-time interactive card playing moment. So I'm illustrating this one. I want you to think about there's a common theme of the future work play in these two visions that I've shown you. And I consider those as mixed reality. So you might wonder, what is mixed reality? The mixed reality is a term coined by Paul Milgram and his colleagues in 1995 paper, and they consider the reality virtuality continuum as going from a real environment, and then real environment augmented by the virtual reality technology. For example, one of the augmented reality is the picture shown below is that called application is AR view, augmented reality view. So in this view, you can use your mobile phone to point the camera at your room and then place a digital rendering of the chairs in the room. So you can see how this chair fit in your room in terms of color and size. And the size should be actually truthfully represented in this augmented reality video. And moving even further to the right, you see augmented virtuality. So the difference would be that you are, as the picture below shows, you are in a virtual world, and then if you lift your hand, actually your hand gets rendered in this virtual world. So there's a blend of real, your hand, with a virtual world. And of course, to the rightmost of this spectrum is the virtual environment. And we know that when you play a game and you're entirely immersed in the virtual environment. So if both NSF and Facebook and Meta actually are envisioning the future of work and play as a mixed reality, then you might wonder, what's not to like about reality? Actually, that question has been sort of answered by New York Times bestseller author Jane McGonigal in about 10 years ago. She wrote a book called Reality is Broken, and she proclaimed that reality is broken and we need something better. So instead of kind of discussing in which ways the reality is broken, which might be depressing, I like to flip the question to think about what is our best, most ideal virtuality, and what do we like so much. So you might think about what's on your mind. The answer on Jane's mind, at least, is the games. She believes the games makes us better and also can change our world. Interestingly, so an illustration of that point, think about why the games we believe is the virtuality that we actually like so much. I have this quote from Jane herself that she described games as unnecessary obstacles that we volunteer to tackle. It's by no means a good definition of games, but it points out two important facts about games. First one, unnecessary means actually most of the games are our own creation. So these are in some sense virtue, they are unnecessary. And then we volunteer to tackle, which means we even pay our time and effort and money to play them. So that means we must love them so much. This you can interestingly contrast with your work where you must get paid to get to work, right? And so this is different. So actually we love the game so much, we will actually pay to play them. And the game, so I want to point out the games, I don't know if you play games, but games is being large and even booming industry in recent years. So this is a report in 2021 by Accenture, and they're pointing out gaming is becoming a super platform. And some of the numbers shown kind of support that. And there are estimated 2.7 billion gamers in 2021 in the world. I calculated it's maybe more than it's more than 1/3 of the world population playing games. And in terms of the value of the global gaming industry, both direct and indirect, altogether it's about 300+ billion estimated in 2021. And to make sense of this number, this is more than the global movie industry and the North American sports industries combined. And I don't know if you paid any attention, but for example, as evidence of that on YouTube, the gamers streaming are one of the most leading segment of the influencers on YouTube. There are many videos and live streams of people playing games, broadcast their game playing, and there are many followers. So coming back to the question, can games do games actually provide something better than reality? So there are many to be liked about games. I would just want to point out a few. And games are highly interactive. So if you think about watching TV, you're passively sitting there, and some of the real world activities even less interactive. And games provide good amount of challenge. Not just you can argue that the real world also provide challenges, but that sometimes the challenges are too low or too formidable that we quit. The games are optimized to provide challenge just at the right level so that you're really immersed. And games are known for providing fantasies, as this picture shows. This is a picture from Fortnite, one of the most popular games nowadays. Of course, games provide a good amount of sensory stimulation, whether pictures, audios, and game provide rewards. And increasingly, as the Accenture report points out, games is providing a lot of socialization opportunities. So nowadays, if you want to socialize with our friends and even kids, a better place to go actually is to play a game with them. And there are other important aspects of games that are sometimes reality lacking, or maybe less noticeable, but otherwise important. For example, games provide good growth opportunity. So as you learn, as you play, you can become better. You can see your own self, see yourself making those progresses. And the psychology shows that see your own growth is one of the important factor in intrinsic motivation. And games also provide clear goals and rules. This is actually one of the essential aspects of the games. And not only that, they provide you support for that goal pursuit and give you really good feedback and tight feedback loop, and also eliminate the distractions that might kind of prevent you from being immersed in that goal pursuit. Those several aspects are the hallmark of games, and actually research shows that these are the key aspects that make an activity intrinsically motivating, which means that you are actually willing to participate voluntarily, even though there's no other incentives. So with all of these, coming back to the question of making the world better, can games make the world better? I viewed this can happen in three ways. First of all, games being such a huge industry is already creating value in the sense of offering escape for people to into the game world. Actually, there are many news stories suggest that people sometimes even prefer the game world, the virtual world provided by games, than the real world they live in, and for good reasons. But that's the game's impact on our real world doesn't stop at that. There are other two ways the games could also kind of change or make our world better. One sort of attempt is called serious games. So those are the genre of games that are made with special serious purposes. For example, some of the games are made for exercise games, and there are educational games. There are simulation games that are made to train people on certain aspect of businesses. Right? There are military games that are made, for military training or knowledge. So not only that, even a broader application is called gamification. So the idea of gamification is, rather than making a kind of a new game, we try to shape the real world task by adding a game layer. I'll give you some example of those. One serious games called popular ones, it's been around for many years, maybe for 2 decades, is called Transport Tycoon. And it's a game, simulation game, and you build your transportation system from from I think 1920s to 2030. So you see the technology grows, you grow the transportation, you get inventions, you solve problems in those. By playing this transportation game, Transport Tycoon, you learn a lot about the business of transportation, and so you learn something useful while you're playing the game. That's the purpose of serious games. And what about the gamification? I use the example that I've been seeing every day. So I have two 5-year-old boys, and they're taking an online course that provided by a company called Spark Education. They're providing, tablet-based online courses for young kids. And in this course, the kids learn, patterns, sorting, and logic, and so these kind of useful thinking skills through this gamified environment. So this environment will have 3 virtual characters: a mouse, a monkey, and a bunny. And they show a small video at the beginning, tell their stories, and then there's a challenge. Maybe a dark wizard stole something, and in order to get that back, they actually solve some puzzles or solve some problems. The teacher will be guiding you through this process and explaining, and the kids will actually use the tablet to point and click and play on the screen. And when they are getting it right, and they get stars flying across the screen, and the characters will also do a silly dance to entertain them. In the end, there will be a moment of celebration when all the kids complete their mission, and they will get celebrated, and you may even get some badges and some video clips that kind of celebrate the moment. When I first saw this, I said, wow, this is fun, and I wish I could teach like this, because with this kind of mixture of teaching in such a fun activity and all its animations and kind of embedded in the learning environment. So when I going through this and going back to the beginning, when I show you the mixed reality, you start drawing some parallels. If you compare the type of games that I just introduced with the type of the reality applications that you're seeing, you start seeing parallels. On the right hand, if you think about games are entire virtual creations, and the serious games try to add a bit of real world purposes to it, just like augmented virtuality does. And the gamification is on the other spectrum, so add some augmented real world with some game elements, whereas augmented reality try to add some real, some virtual objects in the real, introduce that into the real world. But they have different focuses. So there are a lot of overlaps between these two type of applications, but they have different focuses. If you think about the entire virtual reality, augmented reality, they are focusing on kind of augment our environment and kind of rethinking our humans' relationship with the environment. Whereas gamification are thinking about rethinking about the task itself. So how do we structure a task so that it's more rewarding and remove the distractions and provide more feedback and progresses, opportunities, and so on. If you go to the virtual world applications, that may not be a clear goal and rules, but there are indeed many overlaps, and they share technology with each other. You can even draw this parallel even further to think about all the intelligence technology that we are actually the previous panel was focused on discussing. So on the one hand, you have artificial intelligence. You have autonomous vehicles. You have robotics that are actually they're out on their own, making decisions on their own, right? You have robot financial advisors. You have chatbots kind of answering questions. So you're actually putting out the artificial intelligence out there to substitute humans in some of the work that humans typically do. And moving a little bit to the left, you have consider human in the loop, where maybe artificial intelligence is still on the front desk, but they have a human supervisor that sometimes step in when there's something went wrong or inadequate, or maybe something or they bring the feedback to the humans, which may go ahead revise the AIs. And on the left of the spectrum, you have intelligence augmentation. So in there, the roles flipped. Still humans will be sitting in the front row. Maybe you're still the financial advisor, but you are not working alone. You're working with the intelligence recommendations. You are working with recommendations, advices from an intelligence system called intelligence augmentation. In general, we think of these as being decision support systems that are supported by the AI technologies. So again, in this parallel, you can see there's a whole spectrum of where we should put technology, in front of human or behind human, right? And but they are different focus. The last one focuses on the intelligence part. In other words, people are limited in our cognitive capabilities, in our decision-making capabilities, and this can be augmented by the intelligence in different ways. I would even, after drawing this parallel, I would even venture that the future work could actually require all three working together, because they are highlighting different areas. They are augmenting or enhancing our realities in different ways, and they could work together. So with gamification, focusing on structure our task activities to make them more rewarding for human beings. And the virtuality kind of remove some of the physical constraints, maybe, make you can travel in time, travel in space, and represent yourself virtually. And so no longer bound by your physical body, you can use avatars. And then artificial intelligence further extend our own intelligence, either through augmented intelligence or actually, just having the artificial intelligence agents do our bidding. I want to illustrate that with one example that actually is the project I've been working on with my colleagues and students in the last 2 years, called SmartPol. It's an augmented instruction system. As instructor, we try to rethink how do we rethink our job of learning. So what I'm showing now is a typical learning. We have instructors, students. You also have a learning management system, Canvas, Blackboards, several systems that students log onto these to get their assignments and submit their assignments, get materials, and instructors go there, download and grade, and submit the grades. One of the challenge of this is, the instructor is so busy, and they don't have the capacity to give individualized attention to students. Sometimes students need to be reminded. Sometimes you need to talk to students, gather feedback, sense their progress, and so on. So one of the technology could help there is why don't you bring in a virtual teaching system, maybe in the form of chatbot, and chatbot can there kind of take over some of the tedious jobs of teachers. For example, they could go answering frequent asked questions. So students, instead of bothering the teacher all the time, they could go answer the chatbot. And this virtual assistant could also do reminders. They can monitor the progress and remind students about something upcoming or something overdue. And they can also go into query students about how they're doing, what they think of the materials, or what we call pulsing. And all of this could feed back to the teacher. So when we have a virtual agent take care of some of these, this allows the instructor can focus on value-added activities. For example, maybe there's some novel questions, or maybe there's some special students that needs to more individualized attention. And that's solved part of the problem. But some of the problems coming from students aren't engaged, because even though this course is very useful, but they have hard time focusing on the course. And so that means we need to structure our activities so that they actually get more engaged. So there you can bring a lot of gamification in, ideas in. Maybe use a leaderboard, maybe giving students frequent feedback and tighten the feedback loop, and maybe set up some kind of competition. And so that addressed part of the issue. The last part of the issue is actually the intelligence part. Both instructor and students may have some limitations, facing some limitation in terms of making sense of the learning progresses. And that's where the AI can step in. So the AI could connect it to learning management systems, getting data from it, and then they can provide learning intelligence. For example, they might predict which students might be falling behind or at risk, and they can let instructors to reach out proactive to such students before it's too late. And the AI could also tell the instructor, hey, this module, the slides or the materials is problematic based on what I learned from student struggles. Maybe you should actually modify this part. They can also provide that kind of intelligence for instructor to improve their materials. And AI could also help the students. Students sometimes don't know where they struggle or how they're doing sometimes, and they need the AI could go in to see the records and start providing personalized recommendations. Maybe they shouldn't go too fast, and maybe they need to go back to revisit a module, or maybe they should follow. Maybe they should practice something more. So all these, we have different pieces working together. We have intelligence, we have gamification, AI, intelligence augmentation. We also have a virtual agents that work along with the real virtual teaching system, working along with the real teacher. So next part, I want to mention that given that there's all these parallels, can we learn something from the gamification that are useful for the AI development? So here's I want to draw a few kind of thoughts that I have about the implication of gamification for AI. First thing I want to mention is what we learn is from the games is responsible design and engagement trap. I call kind of the terms engagement trap because one of the game industry's biggest problems is addiction. So we know the games are super engaging, but sometimes engaging is too much, and they are sort of engineered to make it very engaging. That problem is actually, so when went overboard with the engagement, so created a problem that actually now the headache for the industry. Actually, we see the similar patterns in the social media industry. I just want to mention, some of you may have learned that some certain social media platforms that the algorithms are super optimized for engagement, but oftentimes people find actually the false information, the misinformation actually are 6 times more engaging than actually the true information. So as a result, this platform is spreading those information like wildfire, right? And so why this has happened? How can we prevent the next the AI application from doing the same thing? So that brings me back. I want to mention that one of the reasons we're having this problem is that engagement itself may not be a good indicator of individual welfare. And that actually is suggested by the theories, and the theories that are especially studied in the gamification setting is this theory suggests that people actually have a tendency of making short-term decisions that may come back to harm them in the long run. And this is sometimes called present bias, meaning that we're super focused on the current, either to get the current gratification or to avoid current pain. that only later on we wished we haven't done so. And that creates problem because the companies are looking at these short-term outcomes and thinking that they are representing long-term welfare, but they are not. So the implication of that is that AI designs, and the newer ones, should try to balance between short-term engagement and long-term well-being. Of course, the challenge here is how, because the short-term engagement are very easy to measure. You can look at the clicks, you can look at likes, you can look at all these kind of behavioral indicators that indicate that people are engaged or with the AI. But how can you capture actually how it does in the long run? Actually, we're already seeing some of the issues. I think I read one research shows that in the case of AI, loan application AI, so they're making a decision on whether to grant someone loans. You would think that people are actually striving to get to be fair, so actually they are giving loans to people who may otherwise don't deserve. But this may be a good thing in the short run, in the sense, oh, I get fair allocation of the loan resources. But what they find is, or through simulation, is that it could hurt the same segment that you're trying to protect in the long run. Why this is happening is because in that case, the loans they're getting, they couldn't repay it in the later. So actually, their actually credit scores get harmed in the long run. So actually, they are even less likely to access these resources in the long run. Sometimes the act of trying to protecting this group actually harm them in the long run. So this is a kind of one class of issues that don't get enough attention. And unfortunately, the companies oftentimes don't have this long view about the well-being of the customers. The second, I want to say that technology alone is not a guarantee for success. I want to make a point with this game called Tetris. I don't know how many people played. I remember I played one of these games in the early days. Actually, it's black and white, and maybe on the device. It's actually one of the greatest single-player games. I said so not because I made it up, but actually because one magazine at that time actually rated this game as one of the greatest single-player games. It's very simple technology. It's a single-player game, a simple concept. But it has something that are actually optimized to be successful. It has the feedback loop is very tight. So you see what you're doing, you see the speed of the squares falling, you see the decisions, the consequence of it, you see the scores changing, and you see your skills are advancing or challenging and ramping up. The games also have a perfect balance between challenge and player skills. As you're getting better, the speed of the squares coming will be faster, and you'll still be pressured. So the game tends to put you always on the edge, and that actually the research in psychology and motivation shows that is one of the conditions, the crucial conditions for being super immersed in the activity. It's called what they describe as flow. It gets the meaning from that time flies when you're actually immersed. So I use the example to illustrate that this game has no fancy technologies or graphics, but it's still otherwise a very successful application. In fact, in the gaming world, you actually designers not only need to consider technology, having 3D graphics and high fidelity, high frame rates, and so on, but also actually you need to design many other consider the social aspect, the challenges, the direct development of character storylines. So all of these other are, as earlier panel mentioned, the socioeconomic considerations that matter a lot in addition to technology. What are the implications for nowadays the AI application that we're considering? One which is the metaverse, right? Metaverse major challenge there is to develop the VR technology that are good enough that people feel really immersed and feel seamless experience, right? But would that be sufficient to draw people in the metaverse? I don't know the answer, but I want to mention that to design AI like this, actually you need more than just technical advances, but you also need to consider motivations, social interactions. I want to mention that actually researchers from the management information system field are actually well positioned to do so, because we're not the computer scientists and we're not super focused on techniques. But we also actually know a lot of the social sciences, psychology, sociologies. So therefore, we are able to consider more holistically, to create designs. To illustrate the importance of considering these other aspects, I want to kind of show you this article that mentioned that lessons from Second Life. I don't know if you have played or experienced Second Life before, but it's a decade ago, Second Life is a real innovation. It's an open game, open world games. It's considered one of the first metaverse or major metaverse, where you can go in this world, you can fly, everyone's walking avatars, you can build your virtual houses, build virtual theaters, you can hold virtual conferences there, giving presentations, all sorts of things. But the problem there, at least one of the problem, don't need to describe the whole, but is that, once you actually build this virtual environment, after you have the technology in place, actually the approach to governance in a virtual world is non-trivial. So, so companies do need to think about actually how do you manage, how do you actually govern the social relations, the rules for this virtual world. I want to mention another kind of example that the technology alone may not be enough. Is Amazon's AR view. So as the picture showed earlier, so Amazon actually rolled out AR-based view in a room feature for some category of the products that include furniture, small appliances, toys, and home decorational items. We did a study, everyone believed that this should be, it seems like a good idea, right? Because, as consumers, you might want to check out, would the size fit, would the color look good in my room, right? So you would like to have this feature, but would actually have a positive effect. We went in to analyze the data we collect from Amazon, and then find that actually the AR introduction has a negative impact on product sales across different categories, most of the categories. Our kind of thinking is still tentative, but we think that people don't really like what they see in a more realistic setting. When you place a product in your own room or in your own cluttered room, maybe that give you a bad impression. Not because the product, but maybe the reality is not as good as what you might see in the traditional seller provided picture of the product. As a result, you are not buying them. This may be good, both blessing but also could be a hidden blessing as well, because if you don't buy them, you don't return them later. We didn't have the return data to look into this issue, but this counterintuitive finding is interesting, maybe unintended when the technology is used. So the implication for us, the research is many real-world AI applications may have unintended consequences, possibly because the engineers, the developer that build them didn't think through all of these intended and unintended consequences and how people react to them. One of the interesting story that that I have is, at one time I talked to a game company, and they told me, hey, our team developed this super realistic AI that could actually play like a real player. So they can they feel like they can use this to as a, AI player instead of using a real player. But one struggle they have is they're not sure when to deploy them. Like, I have this AI player in the multiplayer games, when do I deploy it? So they didn't think through when this might be useful. So that brings back to our theory. My viewpoint is, you having a good technology is not, it may not be a guarantee for success. You actually need to go back to look at human behaviors, look at the social interactions to find the needs, identify the needs and the opportunities for deploy the technology. And sometimes even the technology could hurt. Third, I want to briefly mention, I guess not in a very deep way, that the human technology relationship. One of the some of the findings that are frequently occurring in gamification is gamification can backfire. When it does backfire, is when the controlling, people feel like they are controlled by gamification and feel that their data privacy is being invaded, or they feel like they couldn't, because of the gamification, they couldn't make a decision on their own. One of the examples is, Disney had one time has a productivity tracking gamification that workers rebelled against it. They called it, this is just electronic whip. They feel like whipped all the time to work hard, and if they don't work hard, they get penalized. So that's, when the technology is deployed like that, you actually consider the human interest, human motivation, and also the relationship with human beings. When you look at AIs, AI could do similar harms. AI make these decisions sometimes on behalf of humans. So to take autonomy from them. AI is, a lot of AI require lots of detailed data from the users in order to making intelligent recommendations. So the privacy is a big issue for AI. AI could be, one of the most fears of AI is controlling our lives. People are already fearing about that, right? So I think that relationship actually AI should be designed with this, all this in consideration, not just let the engineers drive the direction of the AI applications. I won't elaborate, but luckily, I think there's already good frameworks for responsible AI in this regard. The idea is human-centered values. So throughout the life cycle of AI project, they should put human in the center, meaning that at the beginning, you should actually talk to the target clients, target users, to see their viewpoints, how they would perceive the technology, how would they like to operate, and when you're designing it, you should be respectful of the human users' autonomy, privacy, diversity, rights, and so on and so forth. So that puts the AI development into a very different, different set of objectives than just pursuing the technological advances. I last want to mention that, for research and application, all these are AI we're seeing as very fancy, and they are backed by corporation of a humongous amount of resources. But I want to mention these advanced applications that don't come cheap. We know that from the games, that games don't come cheap. Even the smallest indie games might cost $50K to $750K to develop, not to mention the bigger blockbuster games that are, that could easily go into millions, if not more. And we know that many serious games projects fail because of this. These are good ideas, but first of all, it's expensive to develop a game from ground up. And then these things are kind of fragile because the players can quickly outgrow the games. Once they've gone through once and they feel, okay, I know it, and no longer interested. So their ability to actually continuously engage users will decline quickly, which means if you're not keeping it up, introducing new materials, new challenges, and new other things, then that investment is gone to waste. So that creates a challenge of important considerations. There is ideal that developing super cool, sophisticated technological applications, but would that investment pay off? Is there some good balance to strike here? That's why sometimes we think that gamification might be at least for some area might be a better trade-off, because you try to get the low-hanging fruits without having huge investment or huge burden of cost of maintenance. I believe the AI project can face similar challenges, because developing AI is one thing that may even require huge cost already to acquire the training data, to accumulate the initial customers, reimburse them for participating. But what about ongoing maintenance, right? So you need constantly monitoring performance and things, paradigm shifts, and you need to actually redevelop them and injecting new data and so on. So there may be still a trade-off. I think for the researchers, that's something to consider. Like sometimes we researchers get excited to get into developing like we did, and takes a lot of time, energy, and investment. But these things are non-trivial. I think for corporations as well, it's one thing to talk about fancy technologies, but to deliver or to make a decision or choose the right type of technology, you think about the spectrum. There's different cost and commitment implications and the value cost ratios that needs to be that decision needs to be made carefully, so that you get a good value out of it. Yeah, I think I want to summarize, just these are some random thoughts I had from my research. I want to kind of quickly summarize. Hopefully you get something. I'd be curious to hear your feedback. I want to mention that one of the highlights is that, our reality is often constraining and borrowing in several different ways. And we do see, because of technology advancement, all these technologies and ideas, there's a tremendous opportunities to reimagine future work, and not just future work, but play, learning, exercising, pro-social activities. And we can certainly, will be revolutionized as the Meta and NSF have kind of already working on. And so there's a great opportunity and for people to enter in this industry. I emphasize that performance AI will be a convolution of technical, social, motivational, and economical factors. So singularly focusing on technology may not be a good idea. And for people who are in a position of making those decisions, I think the holistic thinking is going to be important to avoid some of the mistakes. And then when you're developing these projects, it is again, so needs to be human-centered and throughout the life cycle. And it's very important to balance the short-term gains with long-term welfare. And the reason to highlight there is that because we as humans have our own kind of weaknesses that we're not always consistent with ourselves. So we look at the short-term indicators that may not even consistent with long-term indicators. So when the system is guided by those easy to get short-term indicators, they're doomed to make long-term mistakes. So I think I will conclude with that. And thank you.
Thank you very much, Duh. So if anybody has any, questions from the audience, I do see one question, but feel free to add that into the Q&A, and I'll kind of open it up for that. So the first question from Tom Keeley: the metaverse seems like a space to test AI behaviors. At this stage, is there any dominant platform to test new concepts? Is there anything standardized like Unreal Engine or Unity out there?
I'm not sure, to be honest. So I guess I like to have some clarification on test AI behaviors, because the metaverse is are the kind of the people wearing avatars, kind of walking in there. I'm not sure what test AI behaviors mean in that setting. I
Yeah,
guess.
it could be that, it might be that, maybe having AI agents in the metaverse, if there's some sort of API or SDK that might exist.
Automated.
Yeah, but I'm not sure. Yeah.
Yeah, and there's I think there will be ethical issues, because I think if you think about all these other issues that have bots actually interacting with mixing with humans, like Twitter, that you're gonna get into issues because our users are wearing they're interacting with the AI machine AR agents, and they might be feel that they are mistreated when you're doing that, right? So
right. I mean, I might be biased, but I think the bots will come eventually, right? Like, especially if there's some sort of commerce that's going on in the metaverse. And I think Mark Zuckerberg, it's kind of his $1 trillion bet, right? I think there will probably be some sort of, bots or an automated way that you could create an AI agent. If you already think like what's going on and, things like World of Warcraft and things like that, there were, kind of bots that were out there, but I don't know if there is necessarily an API or a SDK that's out there yet. So besides education, what are the potential applications of VR in other business fields?
So I think I see more of the augmented reality applications than virtual, because I think there are a lot more, like, for example, the remote operations that people can do, can use augmented reality, and so that's a health application. And retail, like I show you this augmented reality, and I've already seen those. The VR, I think virtual reality is more like entertainment or recreational purpose. Like if you want to, I think maybe you can think of what Second Life is being used for. Like I remember there was a case where in the pandemic, people created a virtual ceremony for virtual graduation ceremony in the Second Life kind of environment, where people gather virtually, to hold virtual events. And yeah.
All right. Any more questions for Da? I think we're coming up on time. All right.
So there's a question, I think you can create avatars, but how about adding behavior avatar fully autonomous behavior? I think this is already happening, because avatars can be programmed to have kind of scripted behaviors. They automatically do certain, like if you can think of avatars, they might, when you are not there, logged on, your avatars can react to answer certain. If you say hi, they can do some automatic behaviors on your behalf. So that's actually already blending in. We're already seeing some of that. So you can think of, when you're offline, the avatars can behave on your behalf. There's a suggestion: human on the loop, human off the loop.
Okay. All right. So I guess we can kind of move on to our industry panel. Thank you so much.
Scott, can we take a 3-minute break?
Oh, certainly. Yeah, we can take a couple-minute break here.
Thanks, Delu, for a wonderful presentation.
Thank you.
Thank you.
Okay, so now we'll begin our industry panel on AI and analytics in practice. We've got Guy Russ here from Church Mutual, Steve Luke from Associated Bank, and Brett Young Moxen from Image Mover. Let me just quick, kind of read the prompt here. So analytics and AI at times can overpromise and underdeliver. While we often hear fantastic, conveniently selected stories about the wild successes of AI and analytics in practice, the truth is sometimes misrepresented. Interestingly, Gartner projects that nearly 80% of AI projects will not be deployed in an organization, and only 20% of analytic insights will deliver business value. This panel is curated with 3 panelists from different industries, banking, insurance, and healthcare, to share their perspectives on applying AI and analytics in the real business world. So in this discussion, we'll hopefully discuss, obstacles, successes, and a practical view of the future of analytics in years to come. So, I think it would be really great if we could get the panelists to just kind of introduce yourself, give a little bit of a background and your role, and, briefly describe your company.
Not everybody at once.
Yeah, right. Dr. Schenke, thank you very much. So my name is Guy Russ. I work for Church Mutual Insurance Company, and we're very happy to support and sponsor this event today. I'll start by describing Church Mutual a little bit before myself. So we've been in business for 125 years. So we're one of those old insurance companies located in Merrill, Wisconsin, of all places. My guess is if you're familiar with Merrill at all, it's probably because you drive through it on your way up north to a lake or a cabin or something like that. But that is where Church Mutual was founded. We are currently the largest insurer of religious institutions in the country. But make no mistake, we are a for-profit company. We are not a not-for-profit, but we insure lots and lots of nonprofit organizations like churches, mosques, temples. Really, there's no denominational affiliation from our perspective, so we take all comers. We also insure schools, both public and private, camps, senior living facilities, and all types of nonprofit and human services organizations. Maybe one thing that's a little bit different with our company to the other 2 that are on the panel is we are a commercial insurance company, meaning we do business with other organizations, not individuals or consumers. So things are a little bit different for us from that perspective. But we're property and casualty. We don't do life or health, which means we sell general liability, auto, umbrella, and workers' comp type policies. Myself, I've been with Church Mutual now for 10 years as an employee. Prior to that, I did stints with telco company and also consulting with lots and lots of different organizations, really around applying technology to improve the efficiency and effectiveness of processes. Much of my time at Church Mutual has been doing the same types of things. So working in IT, working in our project management office. I did spend the last 3.5 years in our risk control department. So that was very interesting. And as of January, now I'm in this new role that we call innovation and data. So our innovation program is about 3.5 years old. We started that in 2018. And this is the first time we've actually had a dedicated role just for data. So very, very excited to be on this panel and share with you the types of things that we're doing and our vision for the future.
Really excited to have you.
I can go next. Steve Luke from Associated Bank. Little background on Associated Bank. So we are the largest bank headquartered in Wisconsin. Headquarters is in Green Bay. We also have a pretty big presence here in Milwaukee, where I am coming from today. We're a regional bank, so Midwest footprint, a lot of presence here in Wisconsin, Minnesota, Illinois. We've started growing. We have some auto business now that's starting on the East Coast. Starting to grow our footprint a little bit, but from a retail bank perspective, you'll see us around the state and the general Midwest area, pretty heavily full service retail and commercial bank. Hopefully you guys have seen us. Hopefully you all have your accounts with us. But yeah, so that's associated. Similar to Guy, I am actually, my role here, I head up data management within Associated Bank. And for the first time, that is a dedicated function within our IT organization within Associated. Always kind of fit. We had dedicated roles, but it was kind of within different departments or different areas. We've actually, I've been with the bank about 4 years. We've grown it into its own strategic vertical within IT. So within data management, I own all of our data platforms. We are shifting heavily into a data as a product focus instead of supporting projects around the organization, which we still do, but we're trying to say, how do we offer our data platform as a product for others to build on and enable them? Same thing from an analytics platform perspective. So we have things like Power BI, Tableau that are out there from a dashboarding perspective. We also have the Watson library for advanced analytics, AI, machine learning. We do some AWS things as well that are part of my team. And then the last big piece of us is automation. So RPAs and AI technologies in the RPA space. The other piece I didn't mention is on the data experience side, things like Salesforce. That's a big part of what we do, and we'll get into that maybe in some of the Q&A. But what we found is that not all of our users across the bank are kind of waiting in line for more reporting or more dashboards, right? So what we're trying to do is how do we embed data in those experiences for our users and our colleagues and our customers. So it's a big focus area for us. Prior to Associated, I did some work at BMO Harris. I ran the US data integration team for BMO Harris, came over from M&I Bank as part of the acquisition there prior to that. So quite a few years in banking. Long time ago, I was a COBOL developer at Journal Sentinel. So did, back when newspapers were still an important part of everyone's lives. Ran some of the distribution systems and all the distribution programming for getting that stuff out there. So it's been an interesting journey.
Very cool. Thank you.
All right. Brett Young Moxen. I am currently the head of products at a company called Image Mover, which is a startup healthcare software solution located in Madison, Wisconsin. And we have kind of two sides of the house. So the company for most of its history has been and continues to be focused within the inpatient enterprise healthcare ecosystem. And so primarily we capture visible light images that clinicians need to document patient conditions. So things like wound cares, lacerations, that sort of thing, and then provide them the tools to add structured data to those body part diagnosis, that sort of thing, to be integrated back into the EHR. And there's certainly kind of a machine learning AI pipeline that maybe we'll get into later. We also, since the pandemic, have taken that technology and applied it to diagnostics, so mainly COVID testing. We were approached by the National Health System in the UK to help them document COVID-19 tests for their healthcare workers before they came on shift. And so that's kind of expanded into partnerships with pharmacy chains in the US, as well as the actual manufacturers of these diagnostic tests, be it COVID-19, flu, RSV, that sort of thing. Prior to Image Mover, I was at a startup company in Madison called HealthMine, which was very focused on the volumetric medical imaging study, so CAT scans, MRIs, and specifically giving radiologists the tools to create very accurate 3D segmentations or models of tumors in a patient's body, and then extract higher order metrics from that they don't have access to today, things like volume, density, surface area, that sort of thing. And prior to that, I actually started my career at Epic Systems, which is the world leader in electronic health records, also located in Verona, right outside of Madison. So there I did a whole lot of stuff, but primarily was focused on the laboratory and pathology information systems.
All right, well, thank you so much for your introductions. All right, so I've got a small list of questions here that I think, we can just kind of, if we can kind of collect everybody's sort of thoughts on each question, that would be fantastic. So the first question is, how big of a current role does AI and analytics play in your organization or products? Do you see it as playing a bigger or smaller role in the future?
We could go in inverse order here, maybe. So I'll probably leverage my experience at my previous company where we used AI and ML quite a bit. And I mentioned I was at a company called HealthMind, which was focused on giving novel tools to radiologists as they're reading a CAT scan or an MRI, and allowing them to give inputs on the measurement of these tumors, and then using our own algorithms to extrapolate that out to creating this volumetric 3D rendering, pulling out all sorts of metrics, again, things like density, volume, growth rate, things that critically impact patient care decisions. And it was an interesting journey in that the first few years of the company, we were very focused on more, I guess, traditional computer vision types of technologies, things like computational geometry, Markov modeling, Bayesian statistics, things that as a product manager I can barely spell, but were very useful and more established technologies. And as new research started to be published that showed that machine learning was actually becoming quite practical in that space, we started to augment our technology with ML and kind of default to that when the traditional algorithms were less confident than we wanted them to be. I will end by saying, I think radiology in particular is the space in healthcare where a lot of folks are saying, radiologists are going to be done in the next 10 years. It's just all computers. I have quite a contrarian view to that. I spent quite a bit of time in that space. We had patentable IP and we're constantly comparing ourselves in international competitions and things like that to other governments, technology platforms, all that sort of stuff. And I have not seen that anyone is particularly close to getting us exactly there. But I do think it will increasingly be something that folks leverage. But I don't, again, think that this is going to be the silver bullet that solves all of healthcare's problems.
Yeah.
So from my perspective, I think, data AI analytics is a big part of what we do today. And I think it's massively increasing as we try to remain competitive in the market and kind of differentiate ourselves across some of the other players that are in our space. We've done from an AI perspective, we've seen a lot of increases. We've done a lot in the past where we've partnered with different firms or fintechs. We've purchased some AI-based models. Some of our underwriting solutions now are moving towards more automated decisioning, et cetera. But what we're starting to do more of now is our own in-house development of that, right? So things for fraud and risk analytics, the ability for us to use supervised learning models to say, hey, we've done all this determinations of here's how we've identified fraud in those patterns. And now we can write things that can correlate that together and now apply it instantly on as these new accounts are opened up. So, we're actually getting to states now where we're starting to know that the crime is going to be committed before the crime is committed kind of scenario, which is it's an interesting predicament because it's like, you can't punish until the crime has been committed, right? So we're definitely getting more involved in that space. Fraud is a huge case for us, but I think the other big area that we're seeing is, in banking, and especially kind of regional banking and what Associated Bank we're primarily known for is that customer experience, right? The customer service. You go into the branch, you call our call centers. It's people that are here, right? It's your community. That's kind of one of our big differentiators over the Chase, Bank of America, et cetera. Take a look at these last couple of years. In fact, that we're still doing these virtually, right? And it's definitely, we were going down this path of digitization anyway, but I think the last couple of years have so massively changed how we all interact and what we expect of technology, that now what we're looking at, and we had started this, but I think it's been fast forwarded by years, is how do we take that same personalized customer experience where you waited in line to go talk to Susie Banker because she knew everything about you, right? She knows your family, she knows your kids, she knows, like, you would wait in an extra long line for her because that's your relationship. How do we now offer that same experience digitally, right? So that we can do that at scale. And that to us is the power of AI analytics, right? Is we have to learn all those insights that Susie was able to learn about you. We have to now do that at scale through digital channels. And that's what we think is gonna hopefully keep us differentiated and unique in the market.
AI and analytics, two terms that have very broad, can have broad definitions, right? Or big spectrums on those. Being an insurance company, insurance is all about the promise, right? And at the time we make the promise that we will make you whole up to the limits of the promise or the contract, if you have a claim or if you have something bad happen to you, at the time we write that promise, we have to understand what is the probability that there's going to be a claim and price that appropriately, right? To get to a premium. So insurance has always used analytics to get to that premium. It's just that in years past, it was in underwriters' heads, right? Steve mentioned underwriters on the banking side. Insurance is all about underwriting that risk and trying to predict how likely is it to occur and how bad might it be. So of course, over time, we've been working toward getting that to be more and more automated and get that and have those analytics include more and more factors in our decisions. So we have a lot of data from our history of claims. There's a lot of additional data that's out there now, especially from a properties perspective. So our actuaries have always been sort of that key group of analytical people that have done that analytical part for us. And for the last 10 years now, that actuarial group has been working with what we call a predictive model. So that would be our primary mechanism of automated analytics, getting to the edge of AI, I would say, in terms of deciding what's the right price for this risk based on, we use about 45 different factors at this point to price it appropriately. And we run about 20% of our policies straight through that model that don't even get a look from a human. And then there's about 80% that get a score from the model that gets placed in front of the human, and the human gets to decide, do they take the suggested premium, or do they do something with it based on some other information that they might know that the model doesn't. So that's the role that AI and analytics is playing at Church Mutual. We're currently using version 2.0 of that model, and we're already in the process of creating version 3.0. Outside of actuary, which has always been the primary group for any insurance company, we do have a business intelligence team that we've had for about 10 years. And as you can imagine, they're very operationally focused. So they tend to look backward, right, and try to say, well, what could we learn from things that have happened in the past based on a lot of our operations? So not so much the pricing or underwriting part, but how we're processing things, how we're dealing with our policyholders, those kinds of things. And then with this role that I took up in January, we've decided to stand up our own advanced analytics team. And so we want to move much more toward that predictive or prescriptive type of decision support in the other areas of the company outside of the areas that the actuaries play. Now, our hope is that as we go up and pick up some signals in the data that would suggest some things, that as those become, or as those are proven to be more and more relevant, they might find their way into the actuarial decision-making or components, factors that the model looks at as well. I would say outside of actuary, we don't have any significant AI projects that we've taken on, but Dr. Shanky, we're very happy to be working with you and a couple of members of your team over the summer to put our first one together. So we're excited. For that.
So fantastic. Well, I think some of you guys, kind of highlighted on this next question, but so many worry that AI and analytics is a means to automate job roles. However, others believe that AI enhances workers' abilities to perform their jobs. Which do you believe is an accurate representation at your organization?
I can kick it off. I think what Guy had mentioned, specifically the model where you're using analytics to kind of accelerate a human being's decision making and illuminate what they're looking at is the way forward, at least for the foreseeable future. Based on my experience in healthcare, at least, computers are very good at specific things, right? Crunching numbers, producing data. They are not there yet in some of these more creative endeavors, right? And so again, going back to kind of the radiologist example, maybe I can illustrate my thoughts best through an example. So within radiology, there is a popular kind of sort of study that gets published and republished and pretty regularly, and that is they're called inter-reader and intra-reader variability studies. So essentially, the methodology is something like you take a radiology. These are not junior. These are typically very well established, skillful radiologists, and you put them in front of some array of cancer studies, for instance, and have them measure the lesions on, a dozen, 2 dozen studies. And then you have them take a 15-minute coffee break. You have them come back and read the same studies in a different order, right? And so obviously the numbers are kind of all over the place depending on what study you look at, but in general, and this is not a shot at radiologists by any means, they're incredibly skillful folks, but even an expert radiologist oftentimes comes up with 8%, 9%, 10% difference in measurements from a lesion that they had measured 15, 20 minutes prior, right? And so again, I don't say that to throw shade at radiology by any means, but I think it kind of speaks to the difficulty of applying some other novel technology to get a read, because if you can't even get a radiologist to exactly agree with their own expert reading 20 minutes prior, how can you possibly expect a computer to come in and provide them with a reading that they look at every time and say, you've nailed it again, right? Like it's just, that's not gonna happen. So I think the way that I have approached this in the past that has been very successful is to bake in these algorithms, technology, machine learning into tools that you're providing them to make them more powerful, but put them in the driver's seat.
I would completely agree with Brett. I think to me, it's complementary, right? What we're trying to do is make the work that they're doing more meaningful, right? And allow them to focus more on doing the things that, and taking the insights and making those decisions that can happen, leveraging the insights and the data and the analytics, right? As opposed to necessarily replacing that function. So I think we're trying to get them, so instead of having to have them, our bankers, our fraud investigators, as an example, trying to look for all these patterns or identify all these different things, they can now actually spend their time doing the physical investigations. They can actually identify completely new patterns instead of just trying to find if patterns that had been followed in the past are still reoccurring. So for us, it helps us scale and grow our organization and keep up without having to kind of always incrementally keep adding roles and people. So scale is a big part of that. I do think there may be some realities of if there are some certain functions that are very repetitive and that they only exist to fulfill some of those, collection points, or that may not be AI or analytics, just from a true automation perspective. There may be some functions like that exist, but I think it's really more opportunities for those resources to either upskill or find ways to use and leverage those insights. But we 100% within our organization are looking at it as a complementary strategy, not as a replacement strategy. It's how do we make what we're doing better, better colleague experiences, better, more personalized, ubiquitous experiences across our customers and our colleagues, to really just help them as opposed to, take the place of anything.
Great. And I agree with both Brett and Steve, similar response, maybe different example, just because it's insurance, right? That enhancing the workers' satisfaction with their job I think analytics and AI is going to help with that, right? And we're seeing that in our business as we've moved off some of those very easy to underwrite risks, and the model just takes care of it. We do some audit on the back end, right, just to make sure we're not getting out of calibration. But in reality, the underwriters are happy to get those off their desk, right? Because those are just more distraction, and you know, they take them time to review them, know what's going on, and then just, you know, it's an easy decision to make. So they'd much rather spend their time on the more complex risks that really tests their abilities, right, and get them into it. The other thing is we've been fortunate, our volumes continue to go up. And of course, in this hiring environment, it's very difficult to keep putting people toward that volume, right? So we have to have tools that can help with this, whether it's taking some things off completely or whether it's helping, you know, give that initial look at what the risk is so that there can be an initial score and then some suggestion on whether we want to take it on or not and at what price. But, you know, as we know also, third point is business continues to speed up, right? And people expect things more quickly. So even though we're not insuring individuals, there's still individuals looking at what we provide back to them as a quote and making a decision on it. And they want to see those faster. You know, it used to be that we could get away with 2 weeks on a quote back to somebody. That doesn't exist anymore, right? It's got to be 2 to 3 days. And we know that's coming down as well, right? People are looking for instantaneous. We're not there yet, but we're going to have to rely on technology to help us get there. And all of our folks recognize that as well. So they're looking forward to more tools and more technology to help them. Right now, there's no fear that jobs are leaving because of technology at Church Mutual.
That's great. So another question. So each of you comes from, you know, kind of industries with stringent data regulations. How has this played a role in analytics at your company? You know, has it inhibited sort of your ability to kind of do analytics, or, you know, has it helped it?
I can jump in on that one. Insurance is regulated by 51 different jurisdictions in the US, right? We don't have one regulator. We've got 51, 52 if you count the feds. So this is a huge issue in insurance, especially when we talk about things like AI and black box AI, right? And machine learning, because even our predictive model has aspects of machine learning in it. And every regulator decides whether or not that needs to be exposed and how much of it needs to be exposed. So in insurance, with insurance products, generally you have to do what's called filing those products, which means making them public for the regulators to view and even all of your competitors. So not only do we have to meet the regulators' standards of what they deem to be fair in terms of offering insurance product without bias, but we have to recognize that anything we share with them gets shared with our competitors. So, you know, automatically you have to think about, okay, how are we putting these algorithms together? How are we exposing the algorithms and the results to our regulators in a way that doesn't give away secret sauce for those algorithms? So yeah, it's I would say it hasn't helped accelerate anything. I hesitate to say regulators hinder us, but they're our partners, right? And we work well with them, but it's definitely another item that we have to be cognizant of as we're considering how we put these things together.
Very similar from our perspective, Guy, on the banking regulations, right? So, you know, we have to make sure from a lending perspective that there's no bias, right? That's introduced by anything and any decisioning that we're taking. Like I mentioned kind of early on, in things like some of these fraud models and where we're starting to know things before they happen, it also has introduced some interesting concepts of what actions are we actually even able to take. And the compliance issues and regulatory issues that come with that, to say, you know, can we not even allow that account to open, period, because of the fact that we have a high probability that it's going to be used for fraudulent purposes. That's a careful line in the sand for us to cross, right? And in some cases, you know, ways and the business has to come along for the journey as well. And there's opportunities to say, we're not going to allow that to be open through that channel, right? So maybe it's not a hard no, but it's you have to now go to the branch, right? If you're going to need this to take further action, because there's enough questions that have been raised for you to open this online, as an example, that, you know, we're going to make you go down a little bit different of a path. But there's definitely a lot of scrutiny that we have. And like Similarly, I don't want to necessarily say it hinders us, but it definitely is a different set of obstacles that we have to be careful of. The other big thing for us is same in that model documentation. And as these models are actually learning and evolving, how do you continually develop and you have to really operationalize the auditability of that model, right? So that it's not just a point in time as it gets deployed. It's you have to document every decision that model has now made, along with the drift detection, bias detection, to make sure that that model isn't starting to go off the rails, and the ability to rein that back in. So it has kind of introduced this whole operationalization discussion within our organization of how do we it's one thing to do it once and provide these insights and spit it out. It's another to actually make it an ongoing part of running your business. So it's a journey we're still on, but definitely something that is difficult to work through and think through, but a challenge we do have to solve, right? We owe it to our customers, not just the regulators, right? But to our customers to make sure that we're doing the right thing.
Yeah, I guess I think kind of in this space, there, in my mind, you know, in healthcare, there's two main components, I guess, to this. There is kind of what data you have the right to, specifically talking about, you know, protected health information. And then there is obviously the regulatory component. And I'll try to stay off of my FDA soapbox here. I don't want to get myself in trouble. But in terms of PHI, I think in general, in my career, the industry is in a pretty decent spot in terms of aggregating any data that you have produced or you reasonably have access to for the improvement of your own product. Obviously, there's been plenty of news stories over the past, you know, 5-6 years of even health systems selling data, and I think that's pretty well shut down by and large. But as long as you structure your business agreements and you know, have reasonable cybersecurity and process protection of that data, I have not run into any significant difficulties keeping PHI that might even originate in a hospital setting expressly for the improvement of your own product. So that's good. On the more of like the regulatory front, I would say, I've worked in, you know, highly regulated companies, from FDA to CE mark to ISO standards and things like that. And something to keep in mind is that a lot of those are, especially in kind of high technology, when you're talking about, you know, software, and certainly when you get into the AI machine learning space, the FDA is not an expert on a lot of these things. I think over the decades, they've gotten quite good at, you know, interpreting pharmacological studies, and even in the medical device space, if you've got a glucose monitor that's measuring a particular analyte, or you've got, you know, certainly something that's shooting radiation into a patient, like those are all medical devices that are highly regulated. And I think that's kind of the FDA, for instance, their wheelhouse. But when you get into you know, again, interpreting results and providing data to a clinician, for instance, there is a gray area there, and you have to kind of, depending on the nature of your software, have to make a decision whether you have to be regulated, what class of device you truly are. And again, staying off my soapbox, if you can afford to avoid FDA regulation responsibly, you should do that.
Okay, so a follow-up question, what has been sort of the biggest obstacle to realizing your organization's visions and goals with AI analytics? Has it been people, infrastructure, data regulations, things like that?
Yeah, I can jump in here. I would say primarily it has been, in healthcare at least, the nature of the data, right? Even I'll go back to maybe an example from like my laboratory days. You you would think that walking into a hospital and even getting your basic yearly blood panel would be the same anywhere you go. And that's actually a very mature industry. Actually, the kind of the first place that computers and databases made headway in healthcare was in laboratories, where you're dealing with thousands of specimens a day and millions of data points per year. Those have been around for 30 plus years. But it's still, you can't just walk from one hospital to the next and expect to even understand the data mapping across time. So actually, like the folks that I think are getting the furthest, even with the lab example, are companies that are distributing their own devices, analyzers and things that run the blood panels, because they understand, because they've produced the actual machine. And if they can get that data to the cloud, which again, I think most healthcare systems are starting to get on board with that being okay. For the majority of my career, even the idea of sending data outside of your firewalls was just unspeakable. I think the industry at large is starting to rethink that for many reasons. But again, it's like, if you're a third party that is trying to do analytics on various pieces of healthcare information, something that's done standardly at one hospital, you might be able to get really good at understanding that data. But the second you go to a different hospital system or even a different clinic down the road, their codes and their data could be entirely different. So that's where it becomes an incredibly complex problem. And I think is why we've struggled in the industry to bring things like AI and machine learning to the forefront and implement them, is because it's just so hard to digest the variability of data.
Interesting.
So I can dive in then. I would say data quality. So it might sound odd for a company as old as ours to struggle with data quality, but really that's what's happened. Over time, as we've transitioned from handwritten ledgers into these monolithic systems that used to be built back in the 80s, that we're still moving off of, where there wasn't a need for a data warehouse because all the data was in that one spot, but it was flat files with RPG code. So I didn't have to do COBOL like Steve, but we've got a bunch of RPG programmers yet that are helping us get off those old systems. But really up until 6 years ago, we didn't even have our first data warehouse. So trying to get the data out of those old systems, number one, and then get it from the different versions of the way we used to code things or the way we used to do things, and how it's been modified over time, and get it into a standard format that today we could say is clean. That's an ongoing effort, and that's been difficult. We've got good people solving it, and we're getting close, which is why we felt confident in launching the advanced analytics team. But I would say that's been our biggest obstacle to really getting to better analytics and better predictions of where we want to go in the future.
And I think similar story from our side and within our organization. I think we've probably had challenges across all things, not just the data itself. That is definitely an element. We early on, we took a pretty good stance on building the foundations of saying, let's go with kind of a data lake style architecture and just bring everything in at least to start and get it all there and available. We have had a lot of challenges though too on the people and the talent side, as well as the infrastructure, and getting all the modern technologies as we've modernized a big chunk of our technology portfolio. It's hard, right? We're changing a lot of things and getting people to think a little bit differently, and kind of to Guy's point of not just, hey, this is what I used to get, or as we migrate to a new modernized system, opening their eyes to the art of what is possible has been challenging. Like, you'll have advocates and pockets that are able, but like from a whole bank collective overall, we're not wholly there yet. We still have some kind of cultural transformations that we have to still continue to go through and change and modernize. And then even on the people side within our own team, the upskilling, the changing of this space, right? The skill sets that we're asking people to come in with now are different than it was even 4 or 5 years ago. Not massively, not these huge time changes, right? Like, this isn't 20 years ago or 30 years ago,
Yeah.
COBOL, right? This is literally just the last couple of years. Like,
Yeah.
you know, having our stack has flipped pretty significantly. So, yeah, we've definitely had some obstacles in that, right?
Mhm.
You know, the other thing that we also struggle with is on the infrastructure side, and maybe it's tied to some of the compliance and regulatory, but trying to just spin up the prototypes and do things quickly and try them and get things working is still hard for us, you know, organizationally. Like it's difficult to do a quick little prototype and pilot something, and make sure that you, as you integrate data from across different systems, do you really have non-production data, right? That we can actually do that with, or is it no? This, in order for this to all talk to each other, it has to really be real. Well, now it has to go through the whole life cycle of it being real. So that's kind of another one of those that we're trying to get smarter at is how do we get stuff that we can do just more quickly and fail faster and succeed faster and all of those things. So
that's great. All right. So the last question I have, and I think we've got some Q&A here, but so we have a lot of students in the audience today. What would be your advice to those students embarking on their careers in this field? You know, is there, you know, specific skills or, you know, what would be your, you know, kind of advice to them?
I can start this one, guys. So, you know, I think kind of baking on what I just went through, the technical skills I think are massive, right? Just making sure, you know, Python's pretty king right now, right? From our space, that's kind of a mandatory, and maybe that's not that dramatically different in the past, you know, some of the prior years. But you know, I think polishing up on and making sure you have the statistical backgrounds, the modeling backgrounds, right, in that space. But I think you also have to be open to the fact that the technology is changing that fast, right? And what you know today and you knew yesterday may not be relevant tomorrow, right? And you have to truly stay on top of this stuff. And in order, I think how you succeed the most is that you actually have to understand the context of it. You have to understand why you're doing it and what you're doing, not just how to do it. And I think that's the biggest thing that we're looking for when we bring folks on is make sure that they understand the context, right? The business side, the intent of why we're doing what we're doing. Because I think when you do that, now the technology becomes that much easier. You can go find out how to now write that in whatever language you need to. It's you really have to truly understand it. I guess my last piece of that is tied to that fail faster mentality of like think prototypes, think like believe in that agile iterative process. And you know, I tell my team all the time, people have probably seen the agile diagrams of like the skateboard before the car and all of those things, right? Do you start with a frame or do you start with a skateboard? And I tell my team all the time, like build more skateboards, guys, right? Like we need to think differently and like build things that work and try it. The thing that I love about data science, the mindset of that is like, it means you're experimenting, right? Like you're trying, like have a hypothesis, like go try something. You know, don't wait for it to be perfect and requirements and all of those things. So that's my soapbox for.
And I'll, if you don't mind, Brett, I'll take on to Steve's because I think some very similar advice. I agree with everything you said, Steve. And I'll add in there that looking for diverse experiences. So unless you're going into a profession, right? So actuaries have very specific things they need to know, right? That's a profession. But if you're not doing that, right, if you haven't chosen a profession that way, and what you are is more of that data scientist where you have that mindset for experimentation, then look for as many diverse experiences as you can to apply that. And so I think that goes along with building more skateboards, right? Build not only more skateboards around the same topic, but more skateboards around different topics, right? Because you know, from that advanced analytics perspective, the team that we're starting to put together, I don't necessarily want somebody that's coming from insurance, because then they think like insurance, right? And what we want is we want to find insights and things about the future that maybe don't apply to the way we do insurance today, right? Or maybe they should be on the outside of what the insurance product itself is and looking for something else that we can add into it. So diverse experiences along the way. Just add that on to Steve's, and then Brett, turn it over to you.
Yeah, I mean, I completely agree with what Steve and Guy have said. I think learn how to think, not what to think, right? Learn how to solve problems, how to identify problems, and then go get good at what you think might help solve that, right? So, I mean, an example from my career is, you know, as a 23-year-old kid going to all these hospitals and installing software for the first time. Some of these folks were coming from paper systems, and they'd spent their entire career just knowing what forms to fill out, or even, you know, in the lab space where, you know, databases and things like that had been around for 30 years. There were plenty of folks that could roll with the punches and learn a new system or a new way of doing things. But there were also plenty of folks that were like, I spent the last 20 years doing this exact system, and I don't even know how to, I wouldn't even know where to start thinking about it differently. And you don't want to be that guy or gal that when your specific and only area of expertise becomes, because like Steve mentioned this, you know, things are changing so fast now, right? The technology that has been around for 20 years in a hospital is not going to be around for 20 more years, right? It's going to be around for maybe 5, and then it's going to be the next thing. So just reiterating what these guys have said, you know, learn how to think, learn how to identify what the real problems are, go meet the people that are dealing with those problems day in and day out in the trenches on the front line, and then go, you know, meet a variety of experts that might have a solution, instead of just becoming an expert at one way to maybe solve it.
Fantastic. All right. Well, that concludes sort of, you know, my questions. I think there was one question in the chat here. Might be a comment, but so one of our interesting experiences in the medical space was to deliver a medical diagnosis and then to explain why other diagnoses would be wrong. This was done when our machine delivered diagnosis was compared to trained pathologists, and the machine diagnosis differed from the human pathologist. In the end, the humans seem to agree to about 5% error. The issue is whether you are the provider of expertise or the consumer of expertise. I think that's a little bit more of a comment. So great. Okay.
I have a question. This is Atish. And this is for Brett. Brett, you made a comment about healthcare data and, you know, how it varies from hospital to hospital. Can you comment about healthcare information exchanges, HIEs? They kind of help standardize the data, right? And also look at the entire episode as opposed to looking at specific encounters, right? So, and I'm working on a project with HIE data, so that's my interest at this point. And, you know, you can see the, you know, from the start to the end, how a patient goes through multiple outpatient, emergency, inpatient encounters and what the outcome is. So do you think that is a good step?
Certainly, yeah. I mean, I think, you know, the HIEs certainly are hugely valuable, but they're also many times hugely labor intensive, right? And so I'll take another, you know, certainly related, you know, the HL7 standard but for those of you not familiar, HL7 is an interface message standard that's been around for decades and decades and decades. And essentially what, and this kind of gets to the crux of the data issues I was mentioning, is that the HL7 standard says, you know, you've got all the whatever, but there's different message types for lab messages or insurance claim messages or whatever it may be. And it says, these are the standard fields that you have to use. The patient name goes here, the insurance or the payer goes here. And then, you know, you get into something like a lab message is like, okay, put the result here. Well, that's great. And that's how a lot of this data exchange and interoperability, which is obviously the huge topic in healthcare for the last, you know, 10, 15 years, that's great. So you can send a patient's record now across the country when they go receive care there. But a lot of that stuff is not going to map exactly into your data model, right? It, almost like a way to think about it is like, is that data that you're going to send in this message, you're going to get that data across the country, but would you be able to graph it against the things that you do in-house, right? The names of those results may be different than what you name, you know, even again, just the basic level of a basic metabolic panel. One of the oldest tests, one of the most standard tests that's done, you might call it something slightly different that doesn't compute when you get that message into your system, right? You might call it a BMP. Someone else that sends you a message might call it a basic metabolic panel, male over 40. Well, that's going to require a human to go in and be like, oh, okay, I'm going to map this to what we call it, sort of thing. So it's like super basic example, but I think illustrates that even very standard, like ubiquitous pieces of data don't always travel well. And so you can get that data and you can store that data. But are you going to be able to do some of these more advanced things like tracking that over time, or even finding an equivalence for what your organization calls it?
Thank you.
Yeah.
Right.
Okay, I want to thank all the panelists. This was such an interesting panel, and the keynote speakers and the panelists for the other session. And finally, a big thank you to Church Mutual Insurance for being the major sponsor, and to our other sponsors, Microsoft, Rockwell, and SAP. Have a wonderful weekend, and we'll see you next year again. Bye.
So